Good afternoon, everybody. My name is Ryan Paxton, and I run the workshop at the Eli Whitney Museum and Workshop. I have been a designer and fabricator for many years. I go back maybe 10 years or so. I use many software programs for designing. Rhino is one of my favorite, so we're going to be using Rhino today to model chess pieces. Chess pieces are a good way to start modeling, and the world is your oyster, I should say. So I'm going to get started with the Rhinoceros 3D demo. I will switch to sharing my screen. So we are modeling for the purpose of 3D printing. So these are some pieces that I modeled last night, and I'm going to redo the whole process so you guys can see. So I'll just start with a new instance of Rhino. So I will open up. I am currently using Rhinoceros 5. The most recent version is Rhinoceros 6. It is not too much different. So if you are using Rhino 6, the commands will be the same. I taught Rhino 6 classes at the library last spring. Okay, so when you open Rhinoceros, it gives you 4 viewing planes: top, front, right, and perspective. That is by default. And it also, I'm just going to start a new file. So it gives you the option for different templates. You can work in large objects and small objects in metric or feet and inches. I'm going to start modeling in inches, and then I will convert it to millimeters at the end, because when we export our STLs, they should be in millimeters for 3D printing. So I'm going to open a new one in inches. And I will just start by working in the, I'll do front plane. So if you double click on your pane down here, it maximizes that, so you're just working in the front view plane. Please unmute yourself if you need to have me slow down. I model in Rhino all the time, so I may tend to go too fast. So I need to have reminders if you aren't keeping up. Okay, so the first thing I want to do is decide which chess piece I want to model. So an easy way to start is maybe just finding an image of basic chess pieces. And I found this image here just searching chess piece profiles. One of my keys to getting a good starting point for anything that I'm modeling is also typing profile, because then you get just a side view of the object that you want to model. So I like this one because they're really basic, pretty easy to trace. So I'll right click on this, save image as, and I'll just call this chess. So I save that to my downloads folder. I can show the download here. And what I will do is actually just drag and drop that image into Rhino, and it's going to prompt me to use a picture frame, wallpaper, environment, or texture palette. I'm going to keep it on picture frame. And now is where we start really getting into how Rhino works. So anytime you perform a function in Rhino, you will get a prompt at the very top white bar up here, and this is your command line interface. I can maximize this so you can see. So it keeps a history of all of the commands that have been done as you're going through the steps of your design. So you can see I created a new file. The next command is picture frame, and it tells you the image that you're using, where its location. And then it's going to give you a prompt. Where do you want your first corner of your picture frame? So I could arbitrarily just click a point on my front view plane here, and it'll start it there. Or I can identify its location. So if I type 0, that'll put it at the origin. So I'm just going to type 0 and press enter. So that's the first corner of my picture frame. And then I do want it to be in plane. So there's two ways to do this. I can hold shift and it will lock it in 90 degrees X or Y. So I'll hold shift and then click. And now I have this image for tracing. As it is now, you can click it and move it around. That could be problematic if you're trying to trace on top of this. Another thing you will see, there are a lot of buttons in Rhino, and it can be quite overwhelming. At the very bottom down here, you will see grid snap, ortho, planar, O-snap, smart track, and gumball. Gumball is this red in the red and green arrows. These allow you to move objects on plane or on axis, and you can also scale. I want to undo that. And so if you turn the gumball off, you don't have that option anymore. I really like using the gumball, so I always have that on. And then your O-snap are ways for your drawing to snap to specific parts. So this, if it's disabled, it disables all of these points or selections down here. So O-snap on. And what this means is anything I draw will predictively like snap to an endpoint if I'm close to one. I don't use near or point too often, so I keep those deselected. Midpoint, center, intersection, perpendicular tangent, quadrant, and knot and vertex. I will use them periodically, like if I'm working with circles, maybe I'll turn quad on or tangent on if I need a line tangent to a circle. Okay, so we have our picture and we want to trace the bishop. Yes. Okay, I'm going to trace the bishop. So I don't accidentally snap to like the image itself. I'll show you an example. Like if I was drawing a line, do you see how it pops up this? Okay, so what I was saying is if my image is unlocked, if I were to try drawing lines and I have my O-snap on, it's going to want to snap to, right now it's trying to snap to the center of that object, and you see that by the rectangle with CEN under my cursor. Or if I get close to, say, a corner, it's going to want to snap to the end point or intersection, or a midpoint. These can be very useful if you want it to snap, but I actually don't want it to snap to any points on this because I'm going to do a freeform line on top of this image. So what I want to do, I'm going to just press escape to get out of my polyline tool. Oops. Okay, and I will select the image and type lock. So this is one of the things I really like about Rhinoceros is the command line interface. It makes for very fast drawing. You don't have to like go up to menus and find the tool you want to use. So I type lock, and now this image is locked. I can't move it. I can't do anything. It's just stuck there in place, which is going to be very helpful for the next step. I'm going to just trace the outline of half of this bishop. And in this particular case, I'm actually going to use this tool up here. This is a control point curve. There are other curve options here. I will stick with the first one and show you how I will draw this. So I'm not going to draw this like spherical part here. I'm just going to start roughly here and start getting a basic outline. We're going to adjust the overall geometry of this in a little bit. I'm going to stop there and then go back to this curve down here, and then maybe click. And notice as I'm drawing, you'll see like the O-snap function turn on occasionally, and you'll see the snap, like if I get close to this, it's snapping to that endpoint or the intersection of those two line segments. Okay, so I have like a rough outline. I am going to do something to help you guys out. I'm going to change the layer this is on so you can see the lines a little bit better. So I'm over on the right side now, and the tabs here, properties, layers, display, and help. There's two ways to change the layer property of objects. You can do it in the properties tab. You can see it's currently on layer default. You can change it by clicking this drop down and changing it to layer 1. And now you'll see the lines are red. Maybe a little bit easier to see. The other way, I just did a Control Z to undo. The other way to do it would be to go into the Layers tab and then right-click on a tab or one of the layers and say Change Object Layer. So now it's on layer 2, the purple layer. Okay, so I need to finish this horizontal line. So rather than drawing a curve, I'm just going to draw a line segment. I can do that by just typing a command line function of line and going from endpoint to endpoint, but that is not quite vertical. So what I could do is hold the shift key, and it will then, oops, shift, and this keeps it orthogonal to the y-axis. So I extended that line beyond where I want this to be because I'm going to now extend this line into the vertical line. So I will type extend because that's what I'm trying to do. So extend, click on the end of the line segment to where you want it to go. And I overlapped these two. And now I can select those two and trim those lines. So TRIM, enter, and then clip away the excess. So we have a pretty good rough shape of this bishop, but it's not quite perfect. So what I can do now is refine the geometry by editing the control points. So to do that, I will type points on. And this shows the control points that I'm using. And I can move control points in and out to change the overall geometry of this shape, or this object here. Same thing for this segment. I need to turn the points on. And you can also delete points too. So if you select a control point and just hit the delete key, that point will go away. So I could accomplish this same, relative shape with just 2 control points rather than 3. Same thing with this segment. I will turn points on, and it does remember past commands. So all I typed was PO, and it's predicting that I want to turn points on. So I hit enter, and the points have been turned on, so I can edit this. Okay, I think that's pretty good. And I just hit escape to exit out of the points on. So when points are on, you'll see these white control points, and then hit the escape key, and the points go away. There's a few things I still need to sketch. I'm going to do a vertical line here. So type line, click this endpoint, and holding shift, I can go down to about here. And that is pretty good. I want to do a circle up here now, so I will type circle. And roughly at the center point, make a circle. And now we have our basic geometry drawn here. I now need to join all of these line segments together, because I have 1, 2, 3, 4, 5 line segments, not including the circle. And I need these all to be one continuous curve. So there's a couple ways to do it. You can select by clicking and dragging the marquee to select all. So selecting from, by clicking and selecting from left to right, it only selects the things that are fully within the selection area. If you select from right to left, it's anything that is touching that selection. So I could say, go left to right on just a part of this circle, and it's going to select the circle. But if I did that from left to right, it won't select it unless it's fully within the selection. So I could select all of those, or I could individually click line segments and hold the shift key, and it will select multiple objects. So by holding shift, I could also select the objects that I want. And now what I want to do with those individual curves is join them together. So in my command line, I will type join, enter, and you will see the results up in your command line interface, 5 curves joined into one open curve. Ultimately, what we are looking for is one closed curve. So we're trying to make a complete closed curve that we can then use to develop into a 3-dimensional model. So now we have, 1/2 of this profile. And what I want to do is just reflect it upon the center of this circle that's at the top. So to do that, I will type mirror, enter, and it asks me start of mirror plane. So where am I reflecting it upon? I want to reflect it upon, I'm using my O snap here, the center of that circle. Center. And it still wants to know like what the plane is. So if you look at the command line now, it says end of mirror plane. So if I were to hold shift, it's going to automatically snap to that. Oops. Let me do that again. Hold shift and snap to this plane here. Another way to do it without holding shift is to turn ortho mode on. And so I can turn ortho on, find the center, and then it will reflect upon that center. Okay, now we have 2 open curves and a closed curve at the top, which is the circle. We need to close the bottom of this, so I will draw a line from the bottom edge here to this endpoint. Select these, join these together. And the last step, I am going to select all 3 of these and then perform a trim. So trim. Sorry, I have a crying baby upstairs. Okay, so I'm trimming away these excess lines, and now I have one open curve here and one open curve here. Select those two open curves and join those together. So now if we select this, you will see in the Properties tab, I have a closed curve. At the very top, it says Type, and it says Closed Curve. That is what I want to then use to generate my three-dimensional model. Okay, so now we've done our two-dimensional sketch. We're going to switch to perspective mode. So down at the bottom, you'll see the tabs. Click perspective, and I can now unlock that image because it is going to be in my way, a little distracting. So type unlock, and it unlocks that. I'm going to move this now to a different layer. Maybe I'll move it to layer 3, and I'll rename my layer to image. And then by clicking the light bulb, I can hide that layer. The layer still exists, but it's just hidden, so I don't see it. Okay, now we have this nice profile of the bishop, and what I need to do is make a revolution. So I'm going to revolve, and it asks me start of the revolve axis, and that would be this midpoint. And the next is end of revolve axis. So that could be the center of that circle. And now it's asking me the start angle. So the start angle could be any direction for this, since we're doing a 360 degree revolution. So you can click anywhere. And by default, the revolution angle is 360 degrees. So if I just hit enter, it's going to do a revolve of 360 degrees. Let's do this again and maybe revolve it 180 degrees so you can see what that would do. 180, and what you get is half a chess piece. Okay, we're going to do that again. Revolve. Oops. Oh, another thing to note too is that if you do a command like revolve, and then let's say I want to do it again, I can just hit enter, and it's going to perform that last command again. So from here to the center of that circle, click 360 degrees, and you get all these lines. The lines are because we're in wireframe mode currently, and to change the viewport mode, you click on this triangle here in this drop down, and you can select shaded, which gives you just a solid shaded object. Rendered. So rendered will give you a fully rendered version of your object. If you were to give properties like object properties, attributes to this object, maybe wood grain using a wood grain texture, you could then render this stuff to be lifelike, but we aren't using this for rendering purposes. So the next one is ghosted. I use ghosted most of the time when I'm modeling. That way I can see, parts inside of parts. When I'm, modeling like complex designs, it's very useful. But for this case, we're just going to stay with shaded. This is getting pretty close, but on a bishop, I'll turn my image layer back on and maybe hide the bishop. There's this little slice in it. And I want to do that because that is a distinguishing characteristic of the bishop. So I can turn my image back off, and I will do that by making a sketch on that front plane that I was drawing on before. And I will draw a line. And this line could be on left or right side, it doesn't matter. And so I'm currently in ortho mode, and it doesn't let me draw in any direction other than 90 degrees, so in plane. So I want to turn ortho off because I actually want to bring that slice down like that. And now I'm going to offset that. So type offset, enter, and we're going to offset it. This is roughly, that looks about right to me. I could then maybe move this around to, where I think it looks right. And like we've been doing all along, I want to turn this into a closed curve. So I'm going to create 2 more line segments, one here, enter. And I don't have to type line again. I can just hit enter, and it will re-perform that same command. So now I have 4 lines, and I want to join them together. So I've joined these together. And now I'm going to go back to perspective mode, and I want to extrude this closed curve to use it as essentially like as a slicing tool to make that slice into the solid object that I have. So I can type extrude, and it's predictively going to extrude curve, which is what I want. So extrude curve, and currently it's extruding one direction. There are many different options here. So you can change the direction, you can change both sides, solid, and so forth. I'm only going to stick with these first 2 options here. So I'm going to click on both sides, and now it's going both ways in the distance that I specify. So I could type 2, and it's going to go 2 inches on either side of that curve. This extrusion is an arbitrary distance right now because it really just needs to be larger than the surface that I'm cutting. So the next thing I can do is then split these parts. So I can select one, type split, and then it's asking me select the cutting object. I will select the other one, press enter, and it has created, I'm just going to move this out of the way, it has created a slice here. So I could delete that, but what it's done is left like a hollow inside, and it would not be a printable object as it is because I need that surface to be complete as well. So what I really need to do now is split the other object. And now if I delete the unwanted parts, oops, I just deleted my curve. Okay, and now you can see I have this surface, this poly surface, and this poly surface. I could join them together and have a closed poly surface. There is another way to do this that is maybe a little bit simpler. There are many ways to complete the same tasks in Rhino. You'll find the ways you like to work. So I'm going to show you how to do this a different way. So I could select both of these and go to solid. And we're going to Boolean 2 objects. And now it is prompting me to click to iterate through the Boolean results. So if I click, that could be a result. Click again, that could be a result, which is our desired result. But I'm going to go through all options here. This is one. And then, this is just the 2 as independent. objects. So that's what we want, and then press enter. And the beauty of doing it this way is that it automatically joins it together. So now we have our closed poly surface. That looks like a bishop. One thing that I would do before printing this is put a chamfer on the bottom edge. So I can do type chamfer, and I can click on, oh, actually, I made a mistake. I need to chamfer the edge. So chamfer edge, and I can click the edge that I want to chamfer. And currently, it's showing me 1 inch. That is way too much. I want to do like maybe a 1/16 of an inch. So 0.0625, enter. .0625. It's rounding up to 3. Enter, enter. And now you can see it's taken that edge off of the bottom. This is one step away from being ready for 3D printing, or maybe 2 steps. First of all, how big is this piece? Let's measure it from a front view. I can do a dimension, DIM for dimension, and I can measure from this bottom to the very top, and it's 5.86 inches tall. That seems a little too tall for a bishop. There technically are like specific heights for chess pieces, and I think I looked it up earlier, and the bishop should be in inches. I think it's 2.75 inches. So what I can do now is select all of these objects and type scale. And I want to scale from this endpoint to this endpoint, and I want that to be 2.75 inches tall. So now it's 2.75 inches. We have the appropriate scale. I no longer need this dimension. And then I can select this. And I need to turn this into a mesh. It's currently a poly surface, but it should be an STL for 3D printed. So the last thing I'll do is mesh, just type mesh, and it's going to ask me fewer polygons or more polygons. I'm going to keep it in the middle right now so you can see the result. So that's like a middle result. I will do a mesh again, and I'll turn this all the way up to more polygons and say OK. So you can see the different results. The file size for this one with more polygons is going to be much larger than this one. I'll do it one more time and show you what it looks like with like the fewest amount here. And then one more time with detailed controls. I can actually specify the density, angle, all of this. I'm not going to go into the details of that, though, for this demonstration. So I will select, let's say, this middle version, and I need to export that as an STL. But before doing so, I must convert this drawing to millimeters, because my 3D printer needs a drawing in millimeters. So what I can do now is go up to my File menu and go to Properties. And in the document properties, I will find Units. And I'm currently working in inches, so I can go down to find millimeters and say OK. And it's going to prompt me if I want to scale it by 25.4. So keeping the same size, but converting it to millimeters. And I want to say yes. So now they look much larger, but they're same size. It's just in millimeters. So now I have this piece here, and I want to export file, export selected. You know it's selected because it's highlighted yellow, and I'm going to just export this to my desktop, and I will call this a bishop. I made export selected. Let me do that one more time. Desktop, select STL. Enter. Okay, and at the library, there are two different kinds of 3D printers now. There's two MakerBots and a new Prusa, and the slicer software for both are different. And I have a 3D printer here at home. It has different slicer software as well. So the slicer for my printer, I use Kira. This is the model I drew yesterday. I could go to solid view. I'm going to actually just delete this model and bring in my new model. So I'm going to open my desktop, my bishop, and say open, and it brings it in. This is something I do want you to see. So this is how it looks rendered with the medium density polygon. And you're getting some red warnings here. These are for overhangs. This is something to think about when you're designing for 3D printing. Printers, you should do like, I mean, 45 degrees is safe. Anything more than 45 is going to be somewhat problematic. So it's giving these warnings here. What I could do in my model is, adjust that geometry by re-sketching. So maybe I turn my points on and adjust some of this geometry here, or maybe even I'm just going to move this over. I could maybe do an intersection of the line to account for. Maybe I want a tangent to that curve. Tangent to this curve here, and then, oops, tangent. So and then I could trim away this excess part and make it better for 3D printing.
Ryan, I had a quick question for you while you're kind of on this topic. Is there a function in Rhino that will predict necessary supports for printing?
So not in Rhino, but in your slicer software, you will get warnings like this. So in Prusa, which uses slicer with a 3 instead of an E, it will know where there's overhangs and print supports if necessary. I highly recommend not using supports. If you can design appropriately, you'll have much better print results. Supports sometimes are necessary. Like if you're doing sculptural objects, sometimes you just need it. But if you can design around it, you'll get better results. So I printed this object without any supports and actually didn't change any geometry. And I'm going to stop sharing my screen for right now and show you one that I printed last night. So can you guys see this here?
Yeah, it looks fantastic. I did adjust the settings so that you all should be able to unmute yourselves and chat if you need. I see Tom says yes.
So that is, I think, about an hour-long print on the Lulzbot printer that I have, and the modeling took maybe a little less than an hour too. So in 2 hours, you could have your own custom designed 3D printed chess pieces. Any questions?
Hey Ryan, I have a question. What's the smallest size you can make? I mean, the printer, of course, has its limitations, but just in the Rhino program itself.
Oh, so that's a good question. In Rhino, I'm going to start a new file. I'll just make a new instance of Rhino. I'll save things later. Let me show you. So we're doing a new file. Do you want to work in millimeters?
Preferably microns or less.
Ooh. So I don't have an option of microns. So I'm going to work in millimeters. And you do have the ability to change in your properties units absolute tolerance. Right now we're at 1/1000th of a millimeter. I could go, I can change the absolute tolerance to, I don't know what the like maximum is. I've never worked in microns, but theoretically, you should be able to work at any scale. And then if you're planning like design for 3D printing, working at like, really, really fine detail like that, you can get very small nozzles for 3D printers to print really tiny parts. So it is possible.
Very cool.
So the distance here roughly is 6.47 millimeters. I can scale this down to, oops. We're at 0.32 millimeters. I could keep scaling down. I don't think there is a limit, not that I know of. Is this for 3D printing?
No, not for 3D printing. It would be for just making models. Yeah.
So we're at like a 10,000th of a millimeter now.
Okay.
That's the cool thing about CAD software is that it is infinitely scalable. So I could just keep scaling this down, and I can specify to like the diameter of a circle. So maybe my diameter is 1/1000th of a millimeter, and that's what I've drawn. If I were to then draw a circle that was 1 millimeter from that center, it's going to look really, really, really big. And you can't even see that one that's a thousandth of a millimeter. But it's there. It does exist, and it is to scale.
All right, great, thanks.
Mm-hmm. Other questions?
Ryan, you used a lot of commands throughout this presentation. Do you have a resource on like an infographic, for instance, on like all the commands or commonly used commands, I should say?
That is a great question. I should make one.
You left.
I saw one for like Blender.
Yeah, I use Blender and have I use that too. But no, I'm sure one exists.
All right. I'll check
No.
around.
Yeah, I just did a quick check and there's a website out there. I'm going to go ahead and put it in the chat for everybody. It's basically just the most commonly used commands for Rhino, and I'll throw it in there for everybody.
Ryan, what was the 3D printer you referenced you were using?
So I have a Lulzbot TAS 6. It's a relatively large print volume, like for a desktop 3D printer. I highly recommend the Prusa.
I was just going to ask you about that. Yeah.
I would, yes, they're the best printers. You can't beat them. They
Right.
are very, very good printers. I recently, I'm just going to get a part to show you that I modeled and printed. So I'm in the process of building a 3D scanner right now, and I've been printing cases for the parts. They house a Raspberry Pi with a camera, and all of these parts are modeled in Rhinoceros and then printed on Prusa Mark III S's. I printed a total of, let's see, a lot. 504 parts, and those printers, I had 4 Prusas printing basically 24 hours a day for several weeks. I think it took me about 3 or 4 weeks to print all of the parts. And the thing I like about, there's many things I like about the Prusas. They have filament detection sensors in them. So if your print runs out of filament, it will just pause the print and prompt you to load new filament in, so you don't lose the prints. My Lulzbot does not have that, so if I were running a long print and it ran out of filament, I lose all of those parts.
Okay.
Another thing, Prusas have removable beds. They're PEI treated steel, and parts stick quite well to them. Do you have experience 3D printing, Tom?
No, I don't. Or I shouldn't say, I 3D printed a couple of things back in school, back in college. But those were the days of, I remember my college purchased a very large 3D printer that was like completely like an encased system, but it was an early day system. So it was still a very rough kind of print, I think.
Mm-hmm.
But I've been looking at the home printers, and that's what I'm interested in.
I couldn't like say anything bad about the Prusa printers. Their support is great. They just, they really believe in 3D printing and are making great printers. You have the option of buying a kit and assembling it yourself, or just buying one that's already built. If you're up for the challenge, buy a kit. I didn't buy kits. I just bought pre-built printers because I needed the tools to work like right away. I didn't have time to build the machines. So
I was going to buy a kit. That's what I was looking at.
yeah. I mean, I think a lot of people really enjoy the kits because they get to know the printer a little bit better. And it's not a bad thing to do because parts, do break over time. It's like any tool. You will have to do maintenance on it, and you have to take care of it. But that's like any tool that you use. And building it from a kit, you will understand how it works a little bit better.
That's what I was thinking. That's
Yeah.
my reasoning behind it, was so I could get a better understanding of.
Then I definitely recommend doing the kit.
Great.
Any other questions?
So Ryan, I'm going to go ahead and put the link to your next class into the chat as well, where you're going over Fusion 360 and how to design nuts and bolts. And then I'm just going to quickly plug, if anybody wants to learn more about Rhino, the library offers subscription to card holders for lynda.com. It's turning into LinkedIn Learning, but they offer a lot of different modeling programs so that you can, continue to practice on a couple of different things in there as well. And if you need a library card, please do feel free to reach out to the library. I know our physical locations are closed now, but we can still get you access remotely. So it's out there.
Thanks so much. Ryan, would you be willing to share your contact info?
Oh, sure. I'll put my email address here.
Great. Thank you so much. Great information. I really enjoyed it.
Thanks, Tom.
Thanks, Ryan.
All right. Bye.
Take care.